We're going to go through the lesson for the benchmark. Remember, you'll be allowed to retake this test once a day through most of the semester. The last week or so we'll be focusing on the final, but for now let's go through and try to understand what's on the test. The main ideas to focus on for the benchmark are, and they're in order that you see on the review, we do a word problem from a graph. It's application basically. There's key characteristics of parabolas we need to understand. Of the three transformations, we work with translations and reflections, but not dilations. Another type of question is forms of quadratic equations. There are three different forms we work with, and all three provide information more readily for specific applications. Standard is especially useful for the y-intercept, and we can tell how the parabola opens. Intercept, or sometimes called factored form, again can help us see if it opens up or down, but also shows the roots or zeros or x-intercepts. Those are all the same thing. And then the third and probably most useful form, especially for transformations, is vertex form. We'll be able to see again the opening up and down, but also the translations left, right, up and down. Fourth, what information is easy to find in each form. And then fifth, creating an equation using 2 points. This is a new skill and we see it towards the end of the review. You should have these ideas in mind as we go through, and I'd like you to have this in your notes. Remember the key features of a word problem. The initial height is the y-intercept. That's going to be where our experiment starts. The highest point occurs at the vertex, and the vertex is going to be the coordinates hk. So when you see the coordinates hk, know that the h is the x position and the k is the y position, or up and down. And in a word problem, the k then is the height and h is the time that that highest point occurs. Domain must be positive values for time, and then generally the range will be positive for most word problems because we're talking about projectile motion where something's flying through the air. All right, let's work on some problems here. From this graph, we can go through all these items. What's the height of the rocket after 3 seconds? This is just relating to reading a graph. So if we find 3 seconds on the x-axis, go up till we find the graph, then go horizontally till we see the height. We see it's 120 meters. What's the maximum height that the rocket reaches? We can look from the graph at the vertex, and we'll put a dot there so that we can identify the height of 140 meters. If we go straight down, we see that it occurs, question C, at 5 seconds. When does a rocket have a height of 60 meters? Instead of looking for the highest point, we look for the value of 60, and we notice, like most quadratics, that we have two values for one output. There are two ways to get there, at 1 second and at 9 seconds. So at 1 second, this height of 60 meters is hit on its way up, and then on the way back down it hits it again. What's the initial height of the rocket? The rocket starts at when time is 0 seconds, so we can estimate this to be about 18 meters high at 0 seconds. When did the rocket hit the ground? It hits the ground when it has a height of 0. As I mentioned, the range we expect to be generally positive, but you should be thinking that there are ways that you could have negative heights for certain problems, but in this course we will never address negative heights. So in this case we look and see that the height of 0 occurs between 10 and 10.5 seconds. We'll just call it 10.25 seconds. The domain then is going to be from 0 to 10.25 seconds, and one of the things to think about there is we don't know what happened at less than 0 seconds. The person who did this experiment could have been handling the rocket or getting it ready to the launch pad. After 10.25 seconds, this rocket could have been picked up, so its height can change. We only are worried from 0 to 10.25 seconds. That's what domain considers, and then the range is going to be all values. A common possible mistake is to look at the starting height of 18 and say that the values go from 18 up to the max of 140, but that's only on the way up. On the way back down, it actually gets all the way down to 0, so we want to look across the whole graph and notice that the range goes from 0 to 140, and we don't repeat values. So even though there is a value of 60 meters on the way up and the way down, we don't list that value twice. Key features to notice on a graph. If you look at the next group of questions, it relates to graphs of parabolas that open up or down and translate left, right, up, and down. Notice that the letter A is going to give us information about how the graph opens. The H will give us information on how it moves left and right. We call that a translation. And then K is the movement up and down, or it's a translation that's up and down. Put a dot where the vertex is so you can focus on that one point, our H and K. It opens down, so we'll use a red to identify negative for down. We use the green to show that it's moved right 8. Again, the standard form is going to be minus. So as we've written in the notes here, think opposite. Minus H is going to be, in this case, minus 8, moves to the right 8, and then up 1, again noticing the scale. Okay, all answers are in the on the back there. You can look for them. These are just some examples so you can look at and understand why those are the answers. This is a new skill. I'd like you to write this down as well. To find the equation given 2 points. It's going to be similar to work we did with point slope form. One of the things we did when we found values of y given a certain x. So we're going to have 4 variables. The equations we use will have 5 places, or 5, I'll call them variables, although some are actually constants. There are 5 unknowns, and I'll give you 4 pieces of information. That leaves us with 1 unknown. And the method we'll use for finding the 1 unknown is to plug in those 4 values, whether it's x and y, h and k in vertex form, or x and y, r1 and r2 for intercept form, is we'll plug in, simplify, undo, and ultimately solve for a, our dilation factor. That number then will be plugged back in with the hk into vertex form, remembering to leave x and y blank, or we'll plug in the a and the either root or both roots into intercept form, leaving x and y, because we like to have variables that we can solve for. So let's do a problem. If you look at this graph, or this information, we see that they're giving us the vertex, so we're going to use vertex form, plugging in the stuff we know. The stuff we know is an h of 1, a k of 4, an x of 2, a y of 0. So we have 0 equals a, the thing we don't know, and x of 2 minus h, which in this case is 1, plus 4. Remember the steps were going to be simplify, undo, solve. Simplify meaning 2 minus 1, that's 1. Squared is 1. And I'll just leave that for now because we know 1 squared is 1. Now we're going to undo plus 4 with minus 4. We get a equals negative 4. The next step is to plug in a, h, and k. So leaving y, we have y equals a, which is negative 4. X we leave minus the 1 squared plus the k, which was 4. And this is our equation. It's tempting to write in the x and y that we know, but we really don't use an equation that has all the letters filled in. We like to have our dependent and independent variables there so we can plug in a value and solve for the other. We'll do another one. Here's an example of another vertex problem. Plug in the values, simplify, undo. In this case, it's a 25, so I'll divide by 25, and then get an a of 1/5. Plug in the a, h, and k, and we're done. Identifying our key information here, we see the root 1 and root 2 are 2 and 6. So a we still don't know. We'll put some parentheses. We're going to plug in everything except a, so I'll put minus 2, minus 6. A little bit deceiving. I can tell the y-intercept. If the y-intercept is 24, then y is 24. But when does the y-intercept occur? It's the value of y when x is 0. So not obvious, but we can figure out that the y-intercept of 24 implies that x must be 0. So we plug that in. Again, simplify. 0 minus 2, 0 minus 6, that should be a negative. Negative 2 times negative 6 is positive 12. We're multiplying. You undo multiplication with division. Do it to one side. You have to do it to the other. A then equals 2. Circle that. Again, don't plug in the x and y. Just plug in what we know about A, R1, and R2. So we get y equals, A is 2. We leave the x, plug in the roots, and that is our final answer for the equation. I'm going to take a moment now to answer the rest of the questions. This was the new skill. How does the parabola open? A couple of ways to figure that out, but I think if we wait until we determine what A is, knowing that A is positive tells us that the parabola opens up. What's the equation of the line of symmetry? A very valuable thing, especially from vertex form. We can just say x equals h. In this case, h is negative 5. We know that even from up here. So the equation for the line of symmetry is x equals negative 5. Use symmetry to name another point on this parabola. This information is a little bit trickier to get at, but it really just comes from the graph. So if we did want to make the graph here, we'd see that one of the points given is the y-intercept at 0, 7. The vertex is at negative 5, 2. Well, if the line of symmetry goes through the vertex, better than I can draw it, we know that it's 5 units from 0 to negative 5. So 5 units to the right gets us up to 7. 5 units to the left of negative 5, out at negative 10, should get us up to 7 due to the symmetry of a parabola. So we can say this other point is negative 10, 7, and we've done the work for the getting the equation of the parabola. Moving on, finding the information about this quadratic, the x-intercepts, notice there can be 2, but the y-intercept there's only 1, and then the vertex will be useful. The x-intercept's pretty straightforward. It's going to be the thing, the number you can plug in for x that makes the whole function equal 0. By the zero product property, if you multiply a 0 anywhere in any of these 3 terms, you'll get 0 overall. Obviously 2 is a constant, it won't change to 0, but I can make x minus 3 0 if I plugged in x equals 3, positive 3, or if I plugged in a 9. So there are 2 x-intercepts. The y-intercept's the value of y when x is 0, so I can plug in 0 here like we did on another problem and say 2. 0 minus 3 is negative 3. 0 minus 9 is negative 9. Negative times negative is positive. I got a 27 times 2. That's positive 54. That'll be our y-intercept. And then our vertex is going to come from this idea about symmetry as well. If our roots are out here at 3 and 9, the axis of symmetry has to go through the middle. Through the middle means the average. If you add 3 plus 9 divided by 2, you'll get that. That number would be 12 over 2, or 6. Half of the vertex, the h, the x-coordinate, is 6. You find the y value associated by plugging in 6, and that'll be our k. We'll do that work over to the right here, maybe in a different color. 6 minus 3 is 3, so 2 times 3 times 3. Notice that it's the same distance, 3 units from root, that's a negative 3 though, from one root to the middle, and then from the other root to the middle, just a sign change. This becomes 2 times 3 is 6, 6 times negative 3 is negative 18. So our vertex is at 6, negative 18. We can ask a lot of questions about quadratics. The challenge is to get the information as quickly as possible and be accurate in getting it. I was just going to say, what's the maximum or minimum? And those are questions we can answer once we know the vertex. in this case, by the way. 2 means it opens up. That means we have a minimum at K. So the minimum is negative 18.